Welcome back to the deep dive. It's funny how sometimes the really big scientific steps forward, they don't come from some grand plan, right? They happen because someone just happened to notice something. Well, something weird.
Oh, absolutely. Serendipity, they call it.
Yeah,
The history of science is just littered with those moments. You're looking for one thing and stumble onto something maybe even more important.
exactly. And that's kind of the story we're diving into today. It tackles a problem that's, let's face it, super common and incredibly frustrating for a lot of people, hereditary hair loss.
Mhm.
And the potential breakthrough involves, well, get this, sugar.
Huh. Yeah, but hold on. Not the sugar you're thinking of for your coffee or anything. It's a specific type, one that's naturally in our bodies. And yeah, the findings are pretty surprising, actually. You sent over those articles in the research paper?
I did, yeah. And that's our mission for this deep dive. We're going to unpack these sources, figure out how this accidental discovery even happened, what this sugar actually is, and crucially, how scientists think it might work for hair regrowth.
Right. And compare it to what's already out there, the current treatments, and then look at, what happens next. Is this really a potential game changer?
So maybe the big question to start is, could something as seemingly simple as a sugar really be part of the answer to hair loss? Or maybe what happens when scientists aren't even looking for a hair loss cure, but find one anyway?
Well, that's pretty much how this story kicks off. It all started, according to the sources, with researchers at the University of Sheffield in the UK working alongside colleagues at Comsat's University in Pakistan.
Okay. And what were they trying to do initially?
Their focus was actually quite different. They were studying wound healing.
Wound healing. How does that connect to hair?
They were looking at how a specific sugar, a naturally occurring one called deoxyribose, affected the healing process when they applied it as a gel to wounds on lab mice. Looking at how fast things closed up, tissue regeneration, that sort of thing.
Right, standard wound healing research. So they're putting this sugar gel on mouse wounds. And what happened? What made them stop and go, huh?
Well, this is the accidental bit. They were watching the wounds heal, but they noticed something else happening around the edges of the treated wounds, the fur. It was growing back really fast.
Faster than usual.
Yeah, noticeably faster than on the mice that didn't get the sugar gel treatment. It was quite striking, apparently. That rapid regrowth right around the lesion.
Ah, okay. That's the moment, isn't it? The unexpected observation.
Exactly. That's what made them pivot. They thought, okay, wait a minute. This sugar seems to be doing something significant to the hair follicles themselves. We need to look into this specifically.
So they switched gears from wound healing to focus purely on hair growth. Okay, but before we jump into that specific study, let's clarify this sugar deoxyribose. It sounds familiar, but what is it exactly? It's not like table sugar, right?
Not at all, no. Deoxyribose isn't something you eat for energy. It's a specific kind of sugar, a 5-carbon sugar, and it's absolutely fundamental, like essential to life as we know it.
Fundamental how?
It actually forms the structural backbone of DNA, deoxyribonucleic acid.
Ah, the D in DNA.
That's the one. DNA holds our genetic code, right?
Yeah.
All the instructions for building and running our bodies. Deoxyribose, along with phosphate groups, makes up the sides of that famous double helix ladder.
So it's literally a building block of our genes. It's naturally inside us, in all our cells.
Precisely. Our bodies make it. And the sources mentioned, researchers can also extract it from DNA using a chemical process called hydrolysis. So yeah, chemically it's a sugar, but its job in the body is structural, foundational, not about sweetness or energy.
Okay, got it. So they have this fundamental DNA sugar. They see it boosting fur growth by accident. And that leads them to design a proper test for hair loss. How did they set that up?
Right. They wanted a good model for what happens in humans, specifically the most common type, hereditary patterned baldness, or androgenic alopecia. So they use male mice that are known to lose hair because of testosterone.
Yeah.
It's a pretty standard animal model for this condition.
Makes sense. And the experiment itself.
They basically shaved small patches on the backs of these mice to create clear areas to watch. Then, every day, they applied a small amount of this deoxyribose sugar gel to the bald skin.
And they compared it to something.
Yeah, they had control groups obviously getting a placebo gel with no sugar. And crucially, they had another group getting treated with minoxidil.
Minoxidil. That's Rogaine, right? The stuff you can buy over the counter.
Exactly. So they were comparing the sugar gel directly against one of the current gold standards for topical hair loss treatment.
And what happened? What did they find?
Well, according to the researchers, the results were pretty impressive. Within just a few weeks, I think the paper tracked it over 20 days, The areas treated with the deoxyribose gel showed what they called robust hair regrowth,
Robust, meaning,
meaning they saw, and I think this is a quote, long, thick, individual hairs growing back in those patches.
wow, long, thick hairs in just weeks. I mean, that sounds really promising, especially for something like patterned baldness. How did it compare to the minoxidil group?
Okay, so this is where it gets really interesting. The study found that the deoxyribose gel was, statistically speaking, as effective as the minoxidil treatment in promoting hair regrowth in these specific mice.
As effective, seriously, as the leading topical treatment.
That's what the data showed in this mouse model, yeah. They quantified it too. The sources say both the sugar gel and minoxidil resulted in about 80 to 90% hair regrowth in the treated spots on these mice.
80 to 90%. That's a very high success rate for both, in this model at least. Did they try using them together? Like maybe combining them would be even better?
You'd think so, maybe a synergistic effect. But interestingly, no. The paper notes that when they tried applying both the sugar gel and minoxidil together, it didn't significantly boost the regrowth beyond what either one did on its own.
Huh. So maybe they work in similar ways? Or one just maxes out the potential?
That's a possibility they considered, yeah. Suggests maybe overlapping mechanisms of action, or that perhaps one pathway they affect is sort of the dominant one for regrowth in this context.
And this was all published, like peer-reviewed?
Yes, absolutely. The findings were published in Frontiers in Pharmacology, so it went through that whole process where other scientists review the work before it gets out there.
Okay, so let's recap. Accidental discovery from wound healing using a fundamental DNA sugar, and it works as well as Rogaine in mice with pattern baldness. The big question then is how? What's the science guess for why a DNA sugar would make hair grow?
Right. That's the multi-million-dollar question, isn't it? And the researchers are definitely digging into it. The main theory, the one mentioned most prominently in the sources, comes down to blood supply.
Ah, blood flow, like we were just saying about minoxidil.
Exactly like minoxidil is thought to work, yeah. The leading hypothesis is that this deoxyribose gel somehow improves blood circulation to the hair follicles. And they actually saw some evidence for this during the study.
What did they see?
They noticed an increase in the number of blood vessels, the tiny capillaries, and also more skin cells proliferating around the areas treated with the sugar gel in the mice.
So more pipes bringing in the good stuff, oxygen, nutrients to the hair follicle.
That's the idea. Hair follicles are like tiny factories. They need a good supply line to churn out hair. If the blood flow is poor, the follicle can shrink, go dormant, or produce weaker hair. One source kind of summed up the researchers' thinking. Better blood supply means a bigger hair bulb, which means more hair growth.
Makes sense, like watering a plant better. Are there other ideas floating around about how it might work? Anything linked to its DNA role?
Yes, there are a few other potential mechanisms they're considering. One ties directly into that DNA connection. Because deoxyribose is a building block, the thinking is it might help with overall cellular health and maybe regeneration or repair of the follicle cells themselves. Keeping the machinery running smoothly through the hair growth cycles.
Okay, like helping the follicle repair itself or stay healthy.
Possibly. Another angle is that it might act as an antioxidant.
Protecting the cells.
Yeah, protecting those follicle cells from damage caused by oxidative stress, sort of like cellular rust that can build up and impair function over time. And then there's also the idea it might have anti-inflammatory properties.
Inflammation is bad for hair growth.
Chronic inflammation in the scalp is definitely linked to some types of hair loss. So if the sugar gel can calm that down, it could create a healthier environment for the follicles to thrive.
So improved blood flow is the front-runner theory, backed by some observations, but it could also be protecting cells, reducing inflammation, or helping with cellular repair, or maybe a combination.
Exactly. The researchers acknowledged they weren't entirely sure of the exact mechanism right away, but the positive results spurred these hypotheses. It's likely complex and might involve multiple factors.
Right. Okay, let's pull back a bit. Thinking about the millions dealing with hair loss, especially the hereditary kind, what's the situation now? What are the main options, and how does this potential sugar treatment compare? It's a huge issue for a lot of people's confidence.
Oh, it's massive. Androgenetic alopecia, that hereditary patterned hair loss, is by far the most common type. The sources say it affects up to 40% of people as they get older. It's a mix of your genes, your hormones, particularly androgens like DHT, and just the aging process. And it looks different in men and women, typically.
And currently, there are really only 2 main FDA-approved drugs for it.
That's right. You've got minoxidil, which we mentioned, Rogaine. It's topical, over-the-counter. It can slow loss and sometimes regrow some hair for some people. But it's not a miracle cure, doesn't work for everyone, and you have to keep using it, usually twice a day. Plus, side effects like scalp irritation can happen.
Okay, and the other one?
The other is finasteride, brand name Alopecia. This one's a pill, prescription only, and mainly for men. It works by blocking the hormone DHT, which shrinks follicles. It's generally seen as more effective at stopping loss, maybe working for 80–90% of men who take it.
But there are catches, right? Not for women, and potential side effects are a concern.
Exactly. It's not approved for women who could become pregnant due to risks to a developing fetus. And for men, while not everyone experiences them, the potential side effects listed in the sources are significant. Things like erectile dysfunction, lower libido, depression, even testicular pain or breast changes. Those risks make a lot of men hesitant or unable to take it long term.
So when you look at those options, minoxidil with its variable results and hassle, finasteride with its effectiveness but serious potential downsides, you can see why finding something new is important.
Absolutely. And that's where this deoxyribose research slots in as potentially really exciting. In the mouse study, it showed effectiveness on par with minoxidil. But critically, the sources described deoxyribose as biodegradable, naturally occurring in the body, and in the mice, at least it didn't seem to cause any significant side effects.
That combination is the key, isn't it? Potentially effective and potentially much safer or gentler.
That's the hope. As the researchers pointed out, treating this type of hair loss remains challenging, and new approaches are needed. Finding something derived from a natural bodily component that works well in early tests that fits the bill for a needed new approach.
It's also worth remembering, though, that not all hair loss is this hereditary type, right? There are lots of other reasons people might lose hair.
Oh, definitely.
Yeah.
That's a really important piece of context. While androgenetic alopecia is the big one, hair loss can be triggered by so many other things: major stress, pregnancy, menopause, thyroid problems, certain medications like chemo drugs, or even some for arthritis or depression.
Nutritional issues, too.
Yeah, deficiencies in iron, protein, zinc, certain vitamins. Even things like fungal infections on the scalp, like ringworm or physical stress on the hair from tight hairstyles. Sometimes even poisoning, friction, smoking. The list is long.
And for many of those, if you fix the underlying problem, the hair can grow back.
Often, yes. Which is why getting a proper diagnosis is key. But this sugar research is specifically looking at that persistent progressive hereditary type, which is notoriously hard to reverse.
Right. And we shouldn't underestimate the impact either. It's often way more than just a cosmetic thing. It can really affect self-esteem, mental health.
Absolutely. Finding better, safer treatments for any major cause of hair loss is incredibly valuable for people's well-being.
Okay, so back to the big question then. The elephant in the room. Does this mouse study mean we're going to be seeing sugar-based hair growth gels on the shelves anytime soon?
Well, this is where we need to manage expectations. Unfortunately, probably not next week. The researchers are very clear on this, and it's the most crucial caveat. The study was done in mice.
Right. The classic, it worked in mice, disclaimer. What works in animal models doesn't always pan out in humans.
Exactly. Our biology is similar in many ways, but different enough that results may not always replicate in humans, or it may slightly differently, as one source put it. We are definitely not just large, bald mice.
Okay, fair enough. So what needs to happen next to see if this does work in people?
The absolutely essential next step is human clinical trials. Proper, well-designed studies involving people with hair loss. These trials need to confirm, first, if it's effective in humans, and second, and just as importantly, if it's safe for human use long-term.
And they need to figure out the details too, right? Like how much to use, how often to apply it.
Precisely. What's the optimal concentration? What's the best delivery method? A gel, a lotion, something else? How often does it need to be applied? All these questions need answers from human trials.
And that whole process, it takes time.
It really does. The sources do mention that the researchers are actively working on getting a clinical trial started, which is great news. But these things will take some time, often years, to go through the required phases before something could ever potentially be approved and marketed as a treatment.
Are they thinking about other uses beyond just typical male or female pattern baldness?
Yeah, there's some mention of potential broader applications. For example, could it help stimulate hair, eyelash, or eyebrow regrowth after chemotherapy? That's another area where hair loss is common and distressing, and gentle, effective options are really needed.
And you mentioned the first study was specifically in male mice modeling male pattern baldness. What about female hair loss?
That's another key area for future research. They definitely need to test this in female mouse models of hair loss and then, assuming positive results, in human women. Hair loss patterns and potentially the underlying mechanisms can differ between sexes.
And like the current treatments, minoxidil and finasteride, if this sugar gel does work in humans, would people likely have to keep using it indefinitely?
That's the strong suspicion, yes. Because hereditary hair loss is an ongoing condition driven by genetics and hormones, it's very likely that any treatment, including this one, would need continuous use to maintain the results. Stop the treatment, and the underlying process likely kicks back in. But again, that needs confirmation in long-term human studies.
It really does highlight what the sources said about this being a badly under-researched area. We need these novel approaches that come from understanding basic biology.
Absolutely. It's a perfect example of how research that starts in one direction, like wound healing, can unexpectedly open doors in a completely different field. You just never know.
We also saw brief mentions in the sources of other research happening, right? Just for context.
Yeah, very briefly. Things like studies looking at red ginseng extract for maybe stimulating hair growth, or even really advanced stuff like attempts to 3D print hair follicles in lab-grown skin tissue for regenerative medicine. So this sugar discovery fits into a broader landscape of ongoing research.
Okay, so we've taken this journey today from a complete accident in a wound healing study to understanding this fundamental DNA sugar, deoxyribose, seeing its potential effectiveness in mice matching minoxidil, no less exploring how it might work through blood flow or other mechanisms, and mapping out the long road ahead through human trials.
It's a really fascinating thread of scientific discovery, showing how basic biological understanding can spark these potential new applications.
But, and it's a big but, we have to keep emphasizing, those amazing mouse results are just the first step. The human trials are everything. That's the hurdle that needs to be cleared before anyone should get too excited about this as a real-world treatment.
Exactly. Exciting science, yes. Proven human treatment, not yet. Patience is definitely required.
Absolutely. Still, it leaves you with a pretty cool thought, doesn't it? I mean, who would have guessed that hiding within the very structure of our DNA, one of the basic building blocks of life itself, there might be a key to tackling such a common and, frankly, frustrating problem like hair loss?
It does make you wonder, yeah. What other simple, maybe overlooked solutions are just sitting there in nature, or even within our own biology, just waiting for the right observation or the right question to be asked?
What makes you think? Well, thank you for joining us for this deep dive into a potentially sweet and certainly surprising development in the world of hair loss research.
My pleasure. It was fascinating to unpack.
We'll definitely be keeping an eye on how this research progresses. Thanks for listening, and we'll catch you on the next deep dive.